Welcome to the DIY Honda Garage channel. Today we're discussing Diagnostic Trouble Code DTC P0193, which indicates a high voltage condition in the fuel rail pressure sensor circuit. The fuel rail pressure sensor plays a crucial role in monitoring the pressure of fuel within the rail, sending critical data to the engine control module (ECM). An issue with this sensor can lead to engine performance problems or inefficiencies. In the Honda CRV models from 2017 to 2022, a high voltage reading from this sensor can trigger the system to malfunction or may even present itself as rough idling or stalling. Troubleshooting this DTC is essential for restoring optimal vehicle performance. We will go through detailed steps to diagnose and fix this error, ensuring your vehicle operates smoothly and reliably. DTC P0193 refers to a high voltage condition in the fuel rail pressure sensor circuit. The fuel rail pressure sensor's primary role is to monitor the pressure within the fuel rail and provide data to the engine control module, ECM, to optimize fuel delivery and engine performance. In the Honda CRV, this sensor is typically located near the fuel rail, making it easily accessible for diagnostics and repairs. A high voltage signal exceeding 4.89 volts indicates a fault in the sensor circuit, potentially leading to incorrect fuel pressure readings. If the ECM detects this high voltage, it can trigger various performance issues, necessitating timely troubleshooting to identify and rectify the underlying problem. Several factors could lead to DTC P0193 being triggered. A primary suspect is a faulty fuel rail pressure sensor itself, which may produce erroneous voltage readings. Another potential cause could be wiring issues, including damaged or frayed wires that interfere with voltage transmission to the ECM. Additionally, poor connections at sensor terminals or within the harness can lead to inconsistencies in signal transmission. Ensuring that all electrical connections are secure and undamaged is vital to diagnosing this issue accurately. Sometimes, an intermittent failure may occur, meaning the problem might not be present at all times, complicating the diagnostic process further. Identifying the root cause from this list is essential for an effective repair. There are several symptoms associated with DTC P0193. One of the most noticeable is engine stalling, which can be alarming and trouble the driver significantly. Poor engine performance is another common symptom, manifesting as rough idling, hesitation during acceleration, or overall reduced power. Drivers will usually notice a lack of responsiveness when this DTC is active. Furthermore, the check engine light will illuminate, alerting the driver to a need for diagnostics. Not addressing these symptoms promptly may lead to more severe engine issues or a failure to start. Understanding these symptoms can assist in early diagnosis, leading to timely and effective repairs to maintain vehicle reliability. The first troubleshooting step for DTC P0193 is to turn the vehicle to the on mode and wait for approximately 2 seconds. During this time, you will utilize the Honda Diagnostic System, HDS, to check specific parameters related to the fuel pressure sensor. Specifically, you need to examine the voltage output from the fuel pressure sensor. If the HDS shows a value greater than 4.89 volts, this confirms the failure indicated by DTC P0193 has been duplicated. If the values do not match the threshold, it may indicate an intermittent failure, suggesting that the connections or terminals may be loose or corroded. In such a case, it's essential to inspect these connections thoroughly before proceeding to further diagnostics. In the second troubleshooting step for DTC P0193, you need to turn the vehicle to the off lock mode, ensuring all electrical processes are halted. After the vehicle is off, disconnect the fuel rail pressure sensor 3P connector to isolate the sensor from the circuit. Next, you will jump terminals A and B within the 3P connector, allowing you to directly simulate the signal that the fuel rail pressure sensor normally provides. Once the jumper wire is in place, turn the vehicle back to the on mode and check the voltage parameters again. If the HDS indicates the conditions have reverted to the expected threshold of more than 4.89 volts, it suggests that the issue lies within the sensor itself, moving you forward to the next step. For the third troubleshooting step, ensure the vehicle is in the off lock mode and carefully remove the jumper wire from the fuel rail pressure sensor 3P connector. This process will reintroduce the original sensor into the circuit. Now, turn the vehicle to the on mode again to perform a voltage measurement. At this stage, you need to measure the voltage between test points 1 and 2 on the fuel rail pressure sensor 3P connector, which helps ascertain if the SG1 wire is functioning correctly. A reading close to 5.0 volts indicates that the wiring and signal pathways are intact. If you receive a different reading, it suggests a fault elsewhere in the circuit, prompting further investigation. The fourth troubleshooting step involves checking for continuity within the circuit. Begin by ensuring the vehicle is turned to the off lock position. The next task is to jump the SCS line using the HDS, which prepares the system for continuity testing. After the SCS is jumped, disconnect the PCM connector C51P to isolate it from the system. At this point, you'll need to check for continuity between specific test points on the fuel rail pressure sensor 3P connector and the corresponding PCM connection. If continuity exists, it indicates that the PF wire is in good condition and is operating as intended. However, if continuity is absent, it signifies an open circuit, necessitating repair of the wiring between the PCM C46 and the fuel rail pressure sensor. For the fifth and final troubleshooting step, repeat the process to check continuity, ensuring the vehicle is in the off lock mode. Similar to the previous tests, begin by jumping the SCS line using the HDS. Then disconnect the PCM connector C51P. You will now measure continuity between the fuel rail pressure sensor and the PCM, focusing specifically on the SG1 wire's connections. If continuity is confirmed, this indicates that there are no faults in this part of the circuit. Conversely, if there's no continuity, that suggests there may be a break in the wiring, necessitating a repair in the SG1 wire between the PCM connection C42 and the fuel rail pressure sensor. Completing this final check helps ensure the reliability of the electrical components involved. After completing the troubleshooting and necessary repairs associated with DTC P0193, it's essential to verify that all repairs were successful. Start by clearing the Diagnostic Trouble Codes, DTCs, from the system using the Honda Diagnostic System, HDS. After the DTCs are cleared, take the vehicle on a test drive, subjecting it to a range of driving conditions to reproduce any prior symptoms. Pay close attention to whether the check engine light illuminates again, which would indicate that the fault persists. Successful verification involves confirming that all systems are functioning normally, with no further DTCs appearing. This step ensures that not only was the specific issue addressed, but also that the vehicle is safe and roadworthy for everyday use. To prevent future occurrences of DTC P0193 and similar issues, implementing routine preventive maintenance is critical. One recommendation is to regularly inspect the electrical connections associated with the fuel rail pressure sensor. Ensuring that all connectors are secure and free from corrosion can help mitigate faults from occurring. Additionally, Replacing any faulty sensors promptly can prevent further complications or damage to the fuel system. Establishing a schedule for checking wiring for damage, wear, or exposure to harsh conditions also contributes to the longevity of the vehicle's components. Taking these proactive steps not only enhances vehicle performance, but can significantly reduce repair costs and downtime in the future. In conclusion, DTC P0193 signifies a high voltage issue within the fuel rail pressure sensor circuit. This code requires urgent attention due to its potential impact on vehicle performance and safety. Comprehensive diagnostics help identify whether the issue lies within the sensor itself, the wiring, or connections. Following the troubleshooting steps allows for an efficient resolution, ensuring the vehicle operates optimally thereafter. Additionally, implementing preventive maintenance measures is vital in avoiding future DTCs. By inspecting, replacing, and maintaining critical components, you can significantly support the vehicle's reliability and longevity. Please like and subscribe to the channel. See you next time.